ecological system is vulnerable to destruction from the introduction of plants or animals outside that system. For example, when a non-native plant is introduced into a new area, it usually does not have its growth checked by the environment. With unlimited food and no predators, the non-native plant grows exponentially, quickly covering, killing, and replacing the endemic native plants. Such a plant is the water hyacinth, which has been called the worst aquatic plant in the world. It is native to South America, but is now a part of the lakes, rivers, and streams in most of the southern United States. The water hyacinth is said to have been introduced into the United States in Louisiana at the World's Industrial and Cotton Centennial Exposition of 1884 and 1885. A Floridian went home with water hyacinth plants and later released them into the St. Johns River. From this beginning, water hyacinths now cause problems such as forming impenetrable mats of floating vegetation. These block boat traffic, prevent swimming and fishing, and prevent sunlight and oxygen from getting into the water. Perhaps the worst effect of the water hyacinth is a reduction of biological diversity in waters in which it inhabits. Water hyacinths double in 6 to 18 days. For the purposes of our investigation, let's say that they double in 12 days. Okay? Also assume that there is unlimited food and that there are no predators. Suppose 4 water hyacinths were put into the St. Johns River. Determine in our group, well, there's only 6 of you, so we can all be a group together today. Is that all right? The information in this problem that will be important later in determining the number. What do you think? 12 days. Why is 12 days important? Okay. So what we started with, right? So let's choose blue today. So we need to know that there are 12 days, that it doubles in 12 days. Did the lights just flash or was that my eyes? Okay, just making sure. It doubles in 12 days. What else is important? We started with 4. Water hyacinths. Nope, still spelled it wrong. C-I-N. Sorry, hyacinths is not a word I normally spell, so I'm sorry for spelling it incorrectly, even though it's literally 5 or 6 times right here. Okay, sorry. After 4 doubling periods, how many days will have elapsed? Be sure to justify each answer in this investigation. Do we always have to justify with a sentence? We don't. But if we're going to not justify with the sentence, we have to be very specific about what we're talking about, right? So a sentence is always acceptable. Can I show you some other ways that are also acceptable? Okay? So after 4 doubling periods, how many days will have elapsed? How are we going to figure that out? So it's the first thing we're going to do, we know the answer right away, right? 48 days. But there's no justification there. So the first thing we're going to do is we're going to say 4 times 12. That will help us know that it's 48, right? Except that means nothing, does it? So 4 doubling periods times 12 what? Days in a doubling period should equal 48 what? Days. Does that make more sense? Because 4 times 12 equals 48 means nothing to me if I go back and look at this later. But now if I go back and look at it later, like if I'm going to study for a test or something, I know what I was writing. Okay? After 96 days, there will have been how many doubling periods? How did you figure that out? Remember, we have to justify, so don't tell me the answer. I don't want to know the answer. I want to know how we got there. 96 days, okay. Divided by 12, because there's 12 days in a doubling period. And that should equal what? 8 doubling periods. Does that make sense? Is this a true statement or a false statement? I hardly ever care about the answer. That's true. Okay? Yes, I want you to get the answer. What's more important to me? How you got there. Okay? Sometimes we can show it mathematically with subtracting things on both sides or multiplying things on both sides. Sometimes we have to show it with words. Okay? And I know it bothers some people to have to show their work. I don't care. Politely and respectfully. Okay? I want you to be able to explain your reasoning. Is that fair? Okay. In 60 days, how many times will the water hyacinth population double? Let's do a sentence this time. Is that okay? Okay. So in 60 days, the population, because I don't want to have to spell water hyacinths again, will double. How many times? 5 times? And our actual justification is 60 divided by 12, right? You okay with that? Now, is the answer important? Absolutely. Okay, I don't want you to think the answer is not important. I just also think how we get there is also important. Okay? What about in 120 days? In 120 days, the population, good, will double. How many? 10 times, because 120 divided by 12 is 10, right? Any questions so far? Okay, now back up here it says in question 5 we're going to make a table to figure out how many water hyacinths were produced from those 4 at any given time. Okay, so let's go ahead and do that now. Problem number 5. 0 days, because that's where we started. We know there was 4 water hyacinths. Yes? After 12 days, that's been 1 doubling period. So 4 times 2. Why are we multiplying by 2? Because it's doubling, right? The doubling is multiplying by 2. So exponentially, that would look like 4 times 2 to the first, right? Which would be 8. Now, go back up 1 level. 4 times 2 to the 0. Are you okay with that exponential version of 4? Because anything to the 0 power is 1. Good. I'm glad you remember that. Good job. Okay. So after 2 doubling periods, that's 24 days, right? So process column would look like what? 4 times 2 times 2, right? Because this was the process column for the one right above it, and now we've had 1 more doubling period. So 4 times 2 squared, yeah, to the second power. Well, what is 2 squared? What's 4 times 4? 16. After 3 doubling periods, how many days is that? 36. Good. What's my process column going to look like here? Yeah, it's going to look like the one right before it, and then doubled again. Excuse me, doubled again. So that's going to be 4 times 2 to the 3rd power. 2 to the 3rd power is 8. 8 times 4? 32. After 4 doubling periods, how many days is that? Excellent. 48. 4 times 2 times 2 times 2 times 2. So that's going to look like absolutely 4 times 2 to the 4th. 2 to the 4th is 16. 16 times 4. Excellent. After 5 doubling periods, how many days is that? 60. Good, because 5 times 12, right? Okay. Process column. Same thing as above, times another 2. So 5 2's, right? 1, 2, 3, 4, 5. So 4 times 2 to the 5th. What'd you say? 128? Excellent. After 6 doubling periods, 72 days. Process column is the one before times another 2. So 6 2's. 1, 2, 3, 4, 5, 6. So 4 times 2 to the 6th. Are you starting to see a pattern here? Anywhere? What do we do when we see patterns? Do we shout them out? No, what do we do instead? Excellent. What is 4 times 2 to the 6th? Excellent. Wait, are you seeing more than one pattern here? In this whole table? Yeah? More than 2? More than 3? Excellent. What about 10 doubling periods? 120. How many 2's go here? Okay. 4 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4 times 2 to the 10th. What is 4 times 2 to the 10th? 4,096. Okay. Somebody tell me one pattern that they see. You have permission now. We're done humming. Okay? Somebody tell me what you got. What pattern do you see? Okay, so on the days it's increasing by 12, but I can also multiply this by 12 to get there as well, right? So that's almost 2 patterns, isn't it? That's awesome. Okay, anybody see another pattern? What you got? Uh-huh. Oh, okay, so we're multiplying by 2. We're doubling on the total water hyacinths. We didn't double from here to here, but that's because they tricked us over here, right? Okay. Anybody see any patterns with these 2 columns?
Here's what I found.
Siri, I was not talking to you. I'm sorry. That was so weird. Is that my watch? Oh my gosh, that was on my watch. I'm sorry. That was weird. Did I say Siri? I'm going to have to go back and listen to see what I said. Okay. So these 2 columns are exactly the same? How do they match? Oh, the exponent is the same as the doubling period, okay? So we talked about already similarities we saw with these 2 columns, right? We talked about similarities for these 2 columns. We noticed that this column doubles every time. That's a lot of patterns, isn't it? Excellent. Develop a oh my gosh, it's almost like we planned it. That we can use to fill in the days and the total water hyacinths column below. Okay? So if we know the days, how do we figure out the doubling periods? Before, we talked about the doubling periods and figured out the days from that. What if we know the days? How do we figure out the doubling periods? Yeah, absolutely. We divide it by 12 and divide it by 12. So if we know the doubling periods, can we know the total water hyacinths? If we know the number of days, don't we really know the exponential version? And isn't that telling us the number of water hyacinths? Okay, so what is it? 4 times 2. Perfect. 4 times 2 to the n over 12 power. Any questions so far? Okay. About how many days would it take for there to be more than 1 billion water hyacinths from the original 4? Any idea how we would figure that out? So we could do that. We could set up this equation equal to 1 billion. The problem is our variable is on our exponent, and you don't know how to solve that yet. You will soon. That's some foreshadowing. But you don't know how to yet. And it's not even time for me to teach it to you yet. Okay? Do you think I could put the equation into my calculator? In a graph? 4 times 2 raised to the x over 12 power? What could I do then? Go to the table? Control T. I said that. Control T. Oh. So I'm so weird today. Well, that's not really different than any other day. Now what do I need to look for? Okay. Here we go. What? Okay. Double, 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 double. Not every number I'm not doubling, right? But every 12 numbers. Okay. But I'm already at 500,000, or 50,000, excuse me. And now I'm at 500,000. Now I'm at 1,000,000. Now I'm at 10 million. 100 million. Almost there. 7, 8, 9. Oh. Right here at 334, I am at 956 million. And at 335, I'm at 1,113,000,000. So what do you think I should put? 134 or 135? So first of all, look at the question wording. About. If I put 334, I'm not quite to 1 billion yet. So is it all right with you guys if I put 335? Does that make sense? Why I would put 335 instead of 334? Okay. So 335 what? Days. And just for some justification, if I'm curious to myself how I found that later, how did I find it? I use the table on my calculator. Okay? Just as a reminder to myself later. Okay? How many years is that? So not even a year. So after not even 1 year, 4 water hyacinth plants turned into... After starting with 4, after not even a year, I have more than 1 billion water hyacinth plants. Do you understand why it's considered the worst aquatic plant in the world? Yeah. Okay. Using your formula, how many water hyacinths would there be after 3 years? Oh, geez. Okay, let's use our formula. So 4 times 2 to the what? Oh, I need n over 12, n being the number of days. All I know is 3 years. So 3 times 365? What is 3 times 365? 1095, thank you. So 4 times 2 to the 1095 over 12. $1.778 times 10 to the 28th. I need a label on this answer though to make it make sense. You just want me to spell it, don't you? HYACINTHS. Okay, let me make sure you understand what this answer looks like. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Can I fix something real fast? I missed a 1. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. There should be a 1 right there. So that means one of these zeros is too many. So now my commas are all off. Ugh. Do you get the idea? Thousands, millions, billions, trillions, quadrillions, quintillions, septillions, sextillions, octillions. Oh my gosh. After 3 years, look how many water hyacinths there are. Suppose growing conditions for water hyacinths were actually ideal, and instead of doubling every 12 days, they doubled every 6 days. Rewrite your formula so that you start with the same water hyacinths, and instead we double every 6 days. What does our new formula look like? N over 6. Oh, geez Louise. Using your new formula, how many water hyacinths will there be after 3 years? 3 times 365, I'm going to get that down just so I have it written. 1095. 4 times 2, 1095 over 6. 3.468 times 10 to the 55th power. Water hyacinths. Do you want me to write that number out for you? Okay, thank you. I will if you want me to, but that's crazy, guys, isn't it? Do you think that the formula will accurately predict the total number of water hyacinths indefinitely? Or are there environmental conditions that might limit it? What environmental conditions might limit it? Maybe a drought? Think about where we are. Where are we? No. We're in Florida, right? We're in Florida and Louisiana, the southern United States. That kind of maybe Texas. I don't know. I haven't specifically gone looking for water hyacinths myself. Maybe now they're developing some predators, because there wasn't any when they brought them here, right? There was no natural predators, which is why they exploded so quickly. I'm sorry, I said exploded. It's cool. Like a hurricane, right? That would for sure that would affect it probably, right? Okay. Even, I know it seems silly, but even too much water, right? Like a flood or something would affect it. Okay. If you are the environmental scientist in charge of reducing the population, what will you try to keep the water hyacinths from completely clogging the waterways? What'd you say? Yes, that's correct. They float on top of the water. A net? Put them in a net? So introduce a new predator? Or are you saying create a new predator? Like Jurassic Park? Is that what you're talking about? Okay. I mean, I'm not judging. You're the environmental scientist. What else? What else might we try? Burn them. Okay. Burn them. Set the whole area on fire. That's not going to hurt anything. Oh, a controlled burn. Okay. So only the flowers burn, not any of the fish or the birds or anything like that, right? Fish are under the water. They could jump out into the fire. They could, yes. I suppose that's true. Anything else that you can think of? So are we being a little silly? Yeah, that's okay, isn't it? Isn't that we have to come up with some ideas. We might as well start with the silly ones. So blow up the sun. Blow up the sun, and then there will be no sunlight for the water hyacinths to grow. Poison the lakes. Okay. Poison the lakes. Yeah, I mean, if we're going to blow up the sun, we might as well poison the lakes, right? Okay. So even though at first we were kind of serious and then we got a little silly, even the things that we thought of at the beginning, would they affect other parts of the environment? Yeah, for sure, right? So this is a big problem, isn't it? Okay. For the record, I want to show you this, because a lot of times I think you see math worksheets as math worksheets and they're not real or anything like that, right? This was a newspaper article. Sorry. Do you guys know what newspapers are? Okay, I'm sorry. This was actually an internet article from March 7th, 2019 that directly relates to this. It was March 7th, so it was not too long after I taught this lesson, because it's usually around this time of year that I teach this lesson. Okay? 4 Canadian wolves are airdropped into a U.S. national park to deal with moose. The moose were dying off faster than the wolves were dying off faster than the moose, and the moose population was exploding. And not only were the moose, there was too many of them even to move around, they were running out of food, and they were dying from starvation, because the natural predators were dying off faster than they were. So in Canada, they caught some wolves. I think they shot darts at them, put them asleep, scooped them up with a helicopter, and lowered the wolves into the park with the moose. And then when the wolves woke up, they ran around and started killing moose. Moose. Guys, do you see how this is directly related to what we're talking about? Isn't that cool? This isn't just a made-up problem. This is real. Okay? Any questions so far? We're scooting along pretty nicely. We're doing all right? Okay. Non-native plants can destroy an ecosystem. Non-endemic animals can do the same. In 1859, 22 rabbits were imported to Australia from Europe. The rabbits found a land with plenty of food and no natural predators. Soon there were so many rabbits they were destroying the island. Guys, we're talking about the island of Australia. There were so many rabbits they were destroying the island. In Australia, the rabbit population was doubling every 6 months. Determine in your group, together as a group, the information above that will be important in determining the number of rabbits at any given time. What you got? So we started with 22 rabbits. Double every 6 months. Okay so far? Explain how to calculate the number of years elapsed after 4 doubling periods. Well, 2 doubling periods per year, right? So 4 doubling periods is what we're looking for. So that would be 2 years. So 2 doubling periods per year times 2 to get to 4, right? So that'd be 2 years. How many doubling periods will have elapsed after 18 months? So 18 months is what we start with, divided by what? 6. Why 6? That's how many months in a doubling period, absolutely, which would give us 3 doubling periods. How many times has the rabbit population doubled after 4 years? How many doubling periods are there in each year? 2. So 4 times 2. 8 what? 8 times. Okay. And let's remind ourselves that there's 2 doubling periods per year. So if we're trying to figure out 7.5 years, we're still doing 7.5 times 2 because there's 2 doubling periods per year, right? So 15 times. Yes? Okay. Ooh, another table. Your favorite thing. Complete the following table to show the number of rabbits from these 22 at the given time intervals. Okay? So think back with me here. If we start, we have 0 months, so that's 0 growth periods because that's when we started. How many total rabbits did we have? 22. Okay? We're going to skip this one for just a second. We'll come back to it in just a second, okay? After 6 months, that's 1 growth period. So what's the process column going to look like? 22 times 2. So exponentially, that looks like what? 2 to the 1, which would be 44, right? Now can we go back to the exponential version right above it? We know what it has to look like. We know the pattern, right? So what is it? Times 2 to the 0. Excellent. Okay. So 0 months, then 6 months, then 12 months, because that's 2 growth periods, right? 2 doubling periods. So 22 times 2 times 2, because it's that one, times another one, right? So 22 times 2 to the second, which is 88. After 12, 3 growth periods is going to be how many months? 18, because 3 times 6, right? Okay. Process column. (22) and 3 twos. So 22 and times 2 to the third. Yeah, I know. I'm sorry. There's a whole lot of 2's here. It's going to get worse down here, right? Okay. After 4 growth periods, how many months is that? 24 months. 1, 2, 3, 4. So 22 times 2 to the fourth, which is 352. After 6 growing periods, notice we skipped. Okay? So this should be 36 now. So 22 and how many 2's? 3, 4, 5, 6. So 22 times 2 to the 6th, right? You got that one yet? Good. 1408. After 8 growth periods, 48 months, 22 and 8 2's. 1, 2, 3, 4, 5, 6, 7, 8. After a while, the 2 doesn't make any sense to my brain anymore. Is that just me or no? Okay, awesome. 5,632. And after 10 growth periods, how many months is that? 60. 22. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 22 times 2 to the 10. 22,528. All right, tell me some patterns you see. Tell me the pattern you see in this column right here. As long as this is going up by 1, we're adding 6 every time, right? Okay. Tell me how these are related, though. We can either divide this number by 6 to get this one, or, yeah, absolutely, multiply this one by 6 to get this one, right? Okay. How are these two related? The exponent is the growth period, right? And then how is this? What's the pattern here? By 2, die 2. It's doubling again, right? Because that's a growth period. Okay. In the table below, write the exponential function. If n is the month, what's the growth period? n over 6. So what's the total number of rabbits? Good. Times 2 raised to the n over 6 power. Excellent. In 1887, there were so many rabbits that the government of Australia offered a reward for a way to control the population. How many growth periods had passed by 1887? So we started in 1887. Let's subtract 1859 to figure out how many years that was. So we get 28 years. How do we figure out how many growth periods there are? There's 2 in every year. So 56 growth periods. Wow. Approximately how many rabbits were there by 1887? So in our exponential version formula, we have 22 times 2 raised to the number of growth periods, right? So 22 times 2 raised to the 56th power. 1.585 times 10 to the 18th rabbits. Whew. Lots of rabbits. What population controls would you have offered? Wildfire. It does kind of sound bad right now, but I understand where you're coming from. Okay. So shooting, can I say that at school? Shooting them? Sorry about that. Hunting. Okay, hunting. That also involves a gun, though. Oh, explosions? Okay, that's better. What? I could use a bow and arrow. Okay. I don't think I could use a bow and arrow, but other people could use a bow and arrow. How about that? Well, I mean, we're just saying ideas. We're not saying practical ideas. So, adding new predators? Or are you talking about creating them again? So, specifically a T-Rex. Okay. So, a vacuum. A really large vacuum. What? A giant hole? Oh, a black hole. Okay. That wouldn't hurt any of the rest of the Earth at all. A black hole. Okay. Oh, a black hole that only sucks out the rabbits. Leaves everything else alone. Okay. I'm sure we can have a conversation with the black hole to explain what we need to happen. So we need Elmer Fudd. Elmer Fudd. Okay. Okay, I'll add that last one. Hire the Avengers. Avengers. Let A be the starting amount, B be the growth factor for a given amount of time, and N be the number of doubling periods. Write an exponential function in terms of N that can be used for any exponential growth situations. Y equals what? A times B to the N. Or specifically, if we're being picky and it's saying function, we would have f of n equals A times B to the N. Any questions? For the record, Florida had a problem with pythons. There are some naturally occurring pythons in Florida, but people had some and they were just releasing them because they realized these are big snakes. And so Florida started offering money to people for bringing them dead pythons. That seems like a good idea, right? Except for the fact that then the government realized that people were literally breeding pythons and killing them and taking them in. Isn't that crazy?